In this example, we have an object with 4 forces acting on it, and we're given the mass of the object, and we're told to find the acceleration. Well, if we know the mass and we need the acceleration, all we need is the force, and we can use the equation acceleration is force over mass. So this is what I'll do. I'll do acceleration is force over mass. The problem is I need to know what to put in for force. It needs to be the net force that is the result of all 4 of those forces combined. That's what I'll put in for F. So the first thing I need to do is find the net force. And to do that, I need to consider the horizontal and vertical motion independently, or the horizontal and vertical forces independently. So let's just look at the horizontal forces first. Horizontally, I have 16 to the left and 12 to the right, and you should be able to see that that adds up to 4 newtons to the left. That's the net force horizontally. Vertically, I have 9 newtons up and 15 newtons down, and you should see that that adds up to 16 newtons down. That's the net force vertically. I have to consider the horizontal and the vertical independently, and when I do, I get one result for the horizontal net force and one result for the vertical net force. So I can draw the mass and draw just those 2 forces acting on it. 4 newtons to the left and 6 newtons down. And so the net force will end up being down and to the left. And I can find that. If this is 4 right here, then this is 4 right there. So I'll write a little 4 right there. And look at this triangle. That's a right triangle, and we know the 6 and the 4, so we can find the hypotenuse. That hypotenuse is a combination of the horizontal net force and the vertical net force, so that hypotenuse is the total net force right there, and that's what I'm looking for, and that's what I'll plug in to my equation down here. So let's do the math. F squared is going to be 4 squared plus 6 squared, and that's 16 plus 36, and that comes out to 52. So F is equal to the square root of 52. And we do that on the calculator, and it comes out to 7.2 newtons. That's the net force. 7.2 newtons in that direction, down and to the left, and a little bit more down than left. And that's the number I'm going to plug in right here for the force. So I have 7.2 newtons for my force, a mass of 3.6 kilograms, and 7.2 divided by 3.6 comes out to 2. And that will be in meters per second squared. So that's the acceleration.